In 10.7, we're going to be dealing with more proofs like we did in 10.6, but the new stuff that we're going to add are we're going to add these things called vertical angles. And I don't think that I've ever defined for you what vertical angles are, so I'm definitely going to tell you what vertical angles are. They are angles formed by two intersecting lines they are across from each other and are always congruent. Scooting this up a little bit. Vertical angles are angles formed by two intersecting lines. They are across from each other. That's important. And they are always congruent. So I'm going to underline or highlight those key words. Let me draw you a picture of what vertical angles look like. And so you can do this one very simply on yours. All you have to have is one intersecting line and another intersecting line, just like that. Two intersecting lines. Doesn't matter which way these intersecting lines are. And then I'm going to put some numbers in here. Okay? I'm going to call this angle 1. I'm going to call this angle 2. I'm going to call this angle 3. I'm going to call this angle 4. Okay? Right now, there are two pairs of vertical angles. There are two pairs. Angle 1 is congruent to. Angle 1 is a vertical angle with the one that is across from it. The one that is on the other side. If this angle 1 is acute, then the other side should also be acute, and it should also be congruent. Which one is congruent to it? Angle what?
3.
3. 1 and 3 are vertical angles. 1 and 3 are congruent because they're across from each other. It's formed by two intersecting lines. That's not the only pair of vertical angles. There's another pair of vertical angles here. Angle 2 is congruent to angle 4. These are vertical angles. And today, you're going to have a bunch of problems that are going to see if you understand that these are congruent to each other. You're going to have to solve for some variables using this fact. The other fact that you're going to have to use with vertical angles are that these adjacent numbers are supplementary. And I don't know if you remember that, but I'm also going to put supplementary angles add to 180 degrees and form a straight line. So when I'm looking at this picture, supplementary angles add to 180 degrees and form a straight line. That means 2 and 3. See how this makes a line and I have this angle right here? Angle 2 plus angle 3. I'm going to write that down. Angle 2 plus angle 3 should equal how many degrees? We're going to use the fact that these two are equal to each other. 1 and 3 are equal, and 2 and 3 add to 180. Those aren't the only ones that add to 180. There's 4 pairs that add to 180. I could also say 3 and 4 add to 180. 3 plus angle 4 equals 180. I could also say 1 plus 4 equals 180. I could also say 1 plus 2 equals 180. So I'm just going to write those examples down. 1 plus 2 is 180. We did 3 and 4. Now I need 1 and 4. Just so you're aware. Those are supplementary angles. Bless you. One other word that you're going to need to know is complement. An angle's complement is the angle that it would take when you add to it to equal 90 degrees. So what we're going to write down is, it's the missing angle that adds to 90 degrees. I'm going to underline that word. Do a little bit of highlights here. Supplementary, complementary. Supplementaries adds to 180. Complement adds to 90 degrees. Two little different things there, but I'm going to highlight them because that's what we're supposed to know. So let's do an example. Something that's going to be a little bit harder. Let's jump to number 3 right off the bat. Number 3 looks like this. Might have.
Very similar.
Let me scoot this up a little bit so you can see. That says 3x plus 10. 3x plus 10. It says 4x minus 40 degrees, and that's y degrees. Now, if I were you, I would not start my problem like this and go this plus this equals 180. The reason why I would not do this first is because there's a variable here that's an x, and there's a variable here that's a y, and those variables are not the same. So it would not simplify easily or at all if you had done the problem that way. What I would do if I were you is I would start off with what I talked about before, and that's with vertical angles. What do I know about vertical angles? The ones that are across from each other are congruent. So when you look at this, what two pieces are congruent to each other that we could use? Did you hear what he said? Do you agree with what he said? The 3x plus 10 is congruent to, or is equal to, what value? If you said 4x minus 40, you're right on the money. Those are the vertical angles. Those are the ones that are across from each other. The obtuse side is congruent to the obtuse side. We're going to put an equal sign right there. They're equal to each other. And now we just do the math. Let's use the subtraction property of equality. If I do the subtraction property of equality, I can subtract 3x from both sides. 10 equals x minus 40. That's because I used the subtraction property of equality. Now I want to get rid of the 40. I'm going to use the addition property of equality. I'm going to add 40 to both sides. And now I know what x is equal to. What is x equal to? 50. Now, some of the problems are going to ask you to find the variable. We found the variable. X is 50 degrees. Some of the problems are going to ask you to find the angle's measurement. So don't think that that means that this angle's 50. What it means is X is 50, and so if I want to know what this angle is, I have to actually plug it back in. Go ahead. So this is part of our answer. But if I want to know what this angle is, right over here, this 3x plus 10, then what I have to do is 3 times 50 plus 10. What is that angle's measurement going to be?
20 degrees.
Try again.
Y or rectangle?
What is this angle going to be?
Degrees and y is 20 degrees.
There we go. Second time's the charm. 150, 3 times 50 is 150 plus 10 is 160 degrees. That angle, this big angle here, is 160 degrees. You need to know that before you can figure out what y is. This angle is 160, and this angle y is supplementary to the 160 degree angle. If you want to figure out what y is, and that's one of your questions, that's part of how did you figure that out, Logan? Right. So what did you do? There you go. 180 minus 160 gave you what y is. Y was equal to 20 degrees. I'm just going to write that down. And this is what you actually have for your 2 answers, number 3. My only words of warning are, make sure you're answering the question. Sometimes you're just finding x. Sometimes you have to plug it back in to find what the bigger angle is. And if you go too fast, you won't see it in time. Okay? You will have to plug things back in. That's all part of it. There we go. We have another proof, and then we have some word problems. Woo, the word problems are going to be rough. Let's do a word problem. Let's jump to number 14. Number 14 says, angle A is 3 times as large as its complement. Angle B. Find the measure of angle A and the measure of angle B. I love these problems, but I know they give a lot of normal Math 1 kids issues, okay? So if you read this and you're like, what the heck, Mr. Paramo? I get it. I know. You can do it, though. I'm going to walk you through how to do it, and you should be able to use what you learn here and apply it to the next 3 problems. First things first. Angle A is 3 times as large as its complement, angle B. The key word here is complement. Complement means that the 2 angles add to something. Do you know what the 2 angles add to? If you don't know, look in your notes. Look higher up here and maybe in orange. Complements add to 90 degrees. Wonderful. Don't want to answer right now, Ray. What's your question?
Is it decimal answer?
I don't think so. It might be. I don't remember. So let's see. The first thing I'm going to recommend that you do is I draw a picture. If it adds to 90, then I like to have this little right angle symbol like this. Like, oh, this is going to add to 90 degrees, a right angle. Angle A is 3 times as large as its complement angle B. So I need to have 2 angles here, and one needs to be 3 times bigger than its complement. So let me see. 3 times bigger. Let's go with something like this, and we'll call this angle A. It looks pretty big, and angle B looks pretty skinny. You all right with that? Angle A, angle B. Angle A is a lot bigger than angle B, yes? Okay. So that's angle A, that's angle B. I'm going to do something right next to it, just so you can see. If this bigger angle is angle A and it's 3 times bigger than angle B, do you know what angle B is? No. Let's do this. Let's put X right here. This is X. B, angle B is a smaller angle. It is an unknown. I don't know how long it is. We can call it X. We could even call it B if we wanted to. It doesn't matter. And this has to be 3 times bigger than that. What's 3 times bigger than X?
Yes.
And when you have X and 3X, or B and 3B, now you have enough information to write an equation. Now you have enough information to write the equation to where you can figure out which each angle is. Ray, I don't need an answer.
No, equation.
Don't need that yet. Okay? I want you all to look. These 2 angles add up to how much? It says it in the word complement. They add to what? So then you should think this plus this adds to 90 degrees. There's your equation. X plus 3x equals 90. Then you're going to combine like terms. Then you're going to use the division property of equality. Divide by 4, divide by 4. I think it does come out to a... I think it comes out to a decimal. Okay, wait a second though. So now remember what the question asked for. Find the measure of angle A and find the measure of angle B. X, what did I find? I found the measure of what angle?
B.
So I found that angle B was 22.5 degrees. I have not found the measure of angle A yet. What do I have to do? I can do it one of 2 ways. I can either multiply by 3, or I can subtract this from 90 degrees. It's up to you. What do you want to do? I heard one person say multiply. I heard one person say subtract. So I'm going to multiply first. I'm going to get 67.5 if I multiply my previous answer by 3. But somebody said subtract, so here's my 22.5. I'm going to take 180 degrees. Nope, it's not 180, Mr. Paramo. It's 90. 90 degrees minus my answer. And I get the same 1. So that's good. That's good to know. Here are 2 answers for number 14. The hardest part of number 14 was reading it and writing the equation based off of what picture we drew. Use your key words. Complementary adds to 90. Supplementary adds to 180. We wrote both of those down. Anything else I really want to highlight? No. 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 Let's end our notes right there.